Hello everyone. In today's lesson, we're going to talk about solving exponential equations. So in example one, it says it's going to be solving by equating exponents. So what that means is we're trying to get the 9 and 81 to be the same base. Now I know that 81 breaks down to 9 times 9, and that gives me the same base of a 9 with the other side. So we have 9 to the 2x power equals 9 squared raised to the 3x minus 2. Notice I put 3x minus 2 in parentheses because I do have to distribute that 2 to the 3x as well as the negative 2. Once I have that, I am going to go ahead and get rid of the bases. And now I have 2x equals 2 times 3x minus 2. And I'm going to solve this as if I was in Algebra 2, or Algebra 1 actually, just solving a regular variable, an equation for x. 2x equals, and then I'm going to distribute the 2. So I get 2 times 3x is 6x, 2 times negative 2 is negative 4, and then I'm going to get the x's on the same side. I'm going to subtract negative 6x to the left side of the equation, and I get negative 4x equals negative 4. I'm just going to move it a little bit to the side here. Negative 4x equals negative 4. Well, I'm going to divide by negative 4 to get x alone, and x equals positive 1. All right, and that is our answer when we are solving. So if you want to double check your work, you can go ahead and substitute this in. So this would be my check. I would do 9 to the 2 times 1 power equals 81 to the 3 times 1 minus 2 power. Well, 9 to the second power, and then this right here breaks down to 3 times 1, which is 3, minus 2 is 1, so 81 to the 1 power. 9 squared is 81, and 81 to the 1 power is 81, therefore it works. So it's one way for me to check my answer to see if I did it correctly by substituting my answer back into the original equation and simplifying. All right, let's look at example 2. It says solve by taking a logarithm of each side. So what we're going to do is we're going to try to get, in all of them, the base with the exponent alone. So we're going to get those alone. Oh, C is already ready to go. And D, we're going to get those alone. So what we have to do is basic operations. So I would subtract 3 first to get that 5 to the x power alone. So I get 5 to the x power alone, and that equals 18. And then once I do that, what you have to do is get rid of the base 5. And one way to do that is to do its inverse, which is log base 5 on both sides. So I'm going to go ahead and do log base 5 of 5 to the x and log base 5 of 18. And what happens is log base 5 and base 5 cancel out, leaving us with x equals log base 5 of 18. Now, this is our answer, but what we want to do is we call it a change of base. I'm just going to write it on here. So we're going to change the base to a 10. So we can go ahead and put it into the calculator and get an approximation. So we have x equals log 18, and I'll put 18 in parentheses, divided by log 5. And once you type that into the calculator, as we did in the lessons prior, you're going to get 1.796. That is our answer for this equation. All right, so well done on that. Now let's go ahead and look at B. In B, we're going to do the same thing and get 10 to the 5x plus 4 power alone first. So we're going to go ahead and get rid of the 8 by subtracting 8, which is the inverse of it. So we have 10 to the 5x plus 4 power equals 27. And then we're going to get rid of the base 10 by taking its log base 10 on both sides. So log base 10 of 10 to the 5x plus 4 power and log base 10 of 27. Now log base 10 and base 10 cancel out, leaving us with just 5x plus 4 equals. And log base 10 of 27 is actually a number. Now what's nice is I don't have to change the base because I can use log 27 on the calculator because a log has a base 10 already. So once I type that into the calculator, I am getting 1.431, and then I would solve this as if it was Algebra 1 by subtracting 4 on both sides I get 5x equals negative 2.569. Divide by 5, and x equals negative 0.514. Okay, so that would be our final answer. And then we could always sub it back in and check to see if we are close to 35. Now, I said close because this is an approximation, so it's not going to be exactly 35. All right, let's look at our third example. Now, what's so nice about this third example is it's already ready to go. The base with the exponent is already alone, so what I have to do is get rid of the base. And since it's a base 4, I have to get rid of it by doing log base 4 of 4 to the 0.6. X power equals log base 4 of 240. All right, log base 4 and base 4 cancel out. We're left with 0.6x equals, and then we're going to go ahead and do the change of base here because I don't have a log with a base 4 on my calculator. So I'm going to go ahead and type log of 240 divided by log of 4 onto my calculator. So we change the bases to base 10. And we're left with 0.6x. When you type that into the calculator, you get approximately 3.956. And then we're going to go ahead and divide by 0.6. 0.6. And x equals 6.588. All right. So we're doing inverses on pretty much all of them. All right, let's look at the last one. Woo, here we go. All right, so we got to get the base alone with the exponent. So we are going to go ahead and subtract 7 to the other side. We get 4 to the 3x power equals 33. And then we're going to go ahead and get rid of the base 4 by doing log base 4 on both sides. So log base 4 of 4 to the 3x power and log base 4 of 33. And what's nice is on the left side, log base 4 and base 4 cancel out, and we just drop that 3x down. And then we end up with log, let's change a base on this one. So I'm going to go ahead and change base so I can type it into the calculator. So we're going to do log of 33. It's a really awkward 33. Divide by log of 4. And when you type that into the calculator, you get 3x equals 2.522. Make sure you're practicing this calculator work with me because it's important that you can do it on your own. Unfortunately, on quiz and test days, we can't really, show you how to do that. We try to have you practice it in class so you are confident in your skills on the day of the quizzes and tests. And then when you divide by 3, we end up getting 0.841, and that is our final answer. All right, well, that's all I have for today and solving. So I hope that was helpful. If you are still struggling, please ask questions in class, and we can't wait to see you. Have a good day. Bye.